So now we'll take an example of where we can use regression equations to predict values. So we know that in a regression equation we have the dependent variable on the left hand side and the independent variable on the right hand side. Now one of the feature of regression analysis is that you can predict the values of one variable based on the value of another. Or in other words, you can predict the value of the dependent variable based on the value of an independent variable. So let us take an example here, where we are given where we are supposed to find the regression lines from the following data, and we have to find the value of x if y is equal to 8 and find y if x is equal to 4. So like I've said in the previous videos, it's always a useful tip is to always write the formulas on the right hand side, or the rough area where you work out the formulas. Okay, it becomes much easier for you. Okay, you know which values to solve first. So we know that we need to find the regression equations, and for that we need to find the arithmetic means of x and y, and the regression coefficients byx and bxy. So in the regression coefficients, to find the regression coefficients, the values that we need are as follows. So what we have done here is we have written down the x and y values. We summed up the x values, divided by the number of pairs of observations, and that is the mean value of x, and we take the square, we get 36. Similarly for y, we add up the y values, we divided by the number of observations, we get the mean value, and if we square that, we get the squared value of the mean. Next we solve for this value, summation x square, which is nothing but adding all the square values, so we get 134. Then we solve for summation ey square, which is the sum of the square of y values, we get 56. And lastly we solve for this value over here and here, which is the sum of the product of x and y values. So 3 into 2 6, 5 into 4 20, 10 into 6 60. We add those values and we get 86. So now we can proceed and find out first of all, calculate the values of the regression coefficients, so that we can substitute the values and find the two regression equations. So let us first write down the two regression equations. So the two regression equations are, let us first write down the regression equation of y on x. So this equation tells us that y is the dependent variable and x is the independent variable. And next we take the regression equation of x on y, where x is the dependent variable and y is the independent variable. Let me write this properly. So now we will first find out the value of the regression coefficient of y on x. So we already know the formula. So now next step is just to substitute the values in the formula. So 1 by n is 1 by 3, summation x y is 86, x mean is 6, y mean is 4. Then summation of the x square is 134. The square of the mean value of x is 36. So we get 86 divided by 3, 6 4s are 24. 134 divided by 3, subtract 36, what we get is 28.67 minus 24, and 44.67, approximately 134 divided by 3, 44.67 minus 36. So this gives us the value of 4.67 divided by 8.67. So the regression coefficient of y on x is 0.54. Next, we solve for the regression coefficient of x on y. Now the formula, remember the numerator remains the same, so numerator value remains unchanged. We've already solved for that, and we got what the result we got is 4.67. So just simply write that value down. The only difference is the denominator. Summation ey squared is 56, and the square of the mean of y is 16. So 4.67, 56 divided by 3, subtract 16. This gives us the value of 18.67 approximately, minus 16, and what we get is 4.67 divided by 2.67, and what we get is b makes y equal to 1.75. That is the regression coefficient of x on y. So now we can just simply substitute the value in those regression equations. From one we get, which is the regression equation of y on x, simply substitute the value. X mean is 4, so again always handy to write formula in on the right side. So 4, 0.54 x minus 6, or y minus 4 equals 0.54 x. 0.54 into 6 is 3.24. You bring y a 4 to the other side, it becomes positive 4, because 4 is greater than negative 3.24. The value will take a positive sign. Five 4 x was 0.76. So which is the regression equation of y on x. Then we find the regression coefficient of x on y, a regression equation of x on y. So from 2 we get, if you remember, the regression equation of x on y is written as follows: y minus y bar. So you simply substitute the values. 1.75, that's regression coefficient of x on y, y minus 4, or x minus 6 equal to 1.75 y. 1.75 into negative 4, we get negative 7. Bring 6 to the other side, we get positive 6, and because negative 7 is greater than positive 6, which will give us 1, so we should take the sign of the bigger number, which is negative, so negative 1. So this is the regression equation of x on y. So now we know what is the regression equation of y on x and the regression equation of x on y. Now next we have to find the value of x if y is equal to 8. So this tells us that y is the independent variable and x is the dependent variable. So we have to find, So y is equal to 8 and we have to find x. What is the value of x? So we already know the regression equation, because this tells us that y is the independent variable, x is the dependent variable. So since x is to be found out, it must be on the left hand side, meaning it has to be the dependent variable. And we already know what is the regression equation of x on y, because if x is on the left hand side, it means it is the dependent variable. So here this gives us the regression, which gives us the regression equation of x on y. It shows us that x is the dependent variable, y is the independent variable. So we already know the regression equation, which is x equal to 1.75 y minus 1. So we simply substitute the value of y. If y is equal to 8, x will be equal to sorry about that, 1.75 into 8 is 14 minus 3, so x is equal to 30. So when y is equal to 8, x is equal to 30. And next we have to find y if x is equal to 4. So we have to, if x is equal to 4, what is the value of y? So this again tells us that since y is to be found out, it must appear on the left hand side. So it is the dependent variable and x is the independent variable. And we've already found the regression equation of y on x, which shows y on the left hand side, x on the right hand side. And our regression equation of y on x is like this. So we simply have to substitute the value of x in this equation, and that is how we find the value of y. 54 into 4 plus 0.76, or y is equal to 0.54 into 4 will be 2.16, 0.76. So your y value is equal to 2.95. So this is how regression analysis through the use of regression equations help us to predict the values of variables, or to predict the value of one variable based on the value of another variable.